Hello and welcome, fellow coders. In today's tutorial video, we are going to have a look at the most powerful data struct that Golang has to offer. And that are structs. Many of you might already be familiar with object-oriented programming languages like Java or Python. And when you hear the word struct, you might already think about objects. But Go is no object-oriented programming language. So if you're looking for concepts like polymorphism or inheritance, I have to disappoint you. Golang does not have these. In this video, I will show you that structs, same as objects, also have methods and something that is similar to inheritance, but no real inheritance though. Okay, now before I talk too much, let's hop into my code editor and first answer the question, what is a struct? A struct is a data type that groups information. So a struct is basically a type that lets you group other types into one type. But they are much more flexible compared to slices and maps. The values of a slice must always be the same type, and the same goes for the keys and values of maps. Structs on the other hand do not have this limitation and can contain many different types. That is the biggest advantage structs have over other collection data types. Usually, structs represent entities of the real world, something like a person which has a name, a last name and an age. To make it more clear, let me show you how you can define a struct in Go. You start off with the type keyword, followed by the name you want your struct to have. In our case, that's person. And then finish the definition with the struct keyword and curly brackets. The types within a struct are called fields. So name is a field of type string, last name is a field of type string, and age is a field of type int. Just as I mentioned earlier, you can now see that a struct is a collection of types grouped into one single type. The cool thing is that a struct is very flexible. If we need another field, we can simply add it. After defining the person struct, you can create an instance of a person like this. One cool thing about VS Code is that by pressing Ctrl and space, it shows me all the fields the person struct has, which my instance did not fill yet. For instance, if I put in my name and press Ctrl space again, it shows me all the remaining fields. Awesome, right? So let's go ahead and fill in all the remaining fields and print out the person instance P. When running the code, you can see that the values for the fields get printed out, but not their names. When printing out structs, one advice that I can give you is that you should use the +v format. By adding the plus sign, the fields of the struct get printed out as well. This is especially useful if a struct has a large number of fields, or when you have a nested struct, so a struct within a struct. Now, if you want the value of a specific field of a struct, you can simply use the dot syntax on your struct instance. This way, you will be able to access specific fields of your struct. See, this time only Thomas gets printed out. One thing to keep in mind when using structs is, structs are value types, meaning that if you create a struct off of another struct, the values get copied. The second person instance is a whole new copy of the first person instance. We can see that by changing the name of P2 and printing both out. Even though we created the second person from the first person, they both are completely independent. This has the following very important implications. If you pass a struct to a function, this will actually create a copy of the struct. This is problematic if your structs are very large and you pass them around a lot. This will actually slow down your application because of all the copy processes that need to take place. What you can do though is that you can use the address of the first person struct, thus defining P2 as a pointer to P. This now lets you use the same memory address when passing structs around. Watch my tutorials on pointers if you want to understand how pointers work in Go. In our case, we can see that changing the name of the second struct now has also changed the name of the first struct. So as you can see, using pointers of structs will prevent Go from creating copies all the time, which will drastically improve the performance of your application. The next thing I want to talk about are methods. Let's say for instance we want to retrieve the full name of our person, based on the name and the last name fields. The easiest way would be to create a function called fullName and use a person as a parameter. This function would simply return a string containing the first name and the last name with the space in between. Pretty simple, right? Within our main function, we can now call the fullName function and pass in P as an argument. Printing out the result of the function gives us exactly what we expected, the full name of P. Even though this works just fine, I think you would agree with me that the fullName function would make more sense as part of the person struct, right? What I mean by that is that instead of passing in a person to a function, it would make more sense to call the fullName function for an instance of a person. And that is exactly what methods are. Instead of passing in person as an argument to a function, we put the person into the receiver argument between the func keyword and the function name. This tells Go that the fullName function has a receiver of type person named P. This is actually the reason why methods are sometimes referred to as receiver functions, just for you to know. Now, when we want to get the full name of a person, instead of passing a person into a function, we take the person instance and call the full name function as a function of the person struct itself. The full name function is now kind of an internal part of the person struct instead of simply hanging loose in our codebase, which makes much more sense, right? Now, the last thing I want to show you is the concept of embedding. As you might know, Go is not an object-oriented programming language, so OOP principles like polymorphism and inheritance do not exist in Go. But there is kind of a similar concept to inheritance, and that is called embedding. Inheritance is defined by a is-a relationship. Let's say for instance that we would define an employee and let it inherit a person. In that case, the relationship would be that employee is a person. So if you would do an equality check of an employee and a person, in OOP languages this would result in true. Well, technically this is not completely correct, but you get the point. In Go, instead of inheriting from a struct, we can embed another struct. The relationship in this case will not be an is-a relationship, but rather a has-a relationship. In our case this means that employee has a person. If you would check the types between an employee and a person, in Go they are not the same. Okay, but how does embedding look like in Go? First, let's define employee struct and add the salary field. The easy way of integrating, but not embedding a person into an employee struct is by simply adding a person field. This way, when defining our employee, we are able to pass and be as a person. And of course, don't forget the salary field. Yeah, I would say this is a reasonable salary for a Go backend developer. Now, if you go ahead and print out the employee instance, you can see that it has the person field and all its subfields like name and last name. Now here comes the fun part. If we want to access the name field of the person within an employee, we first need to access the person and then have access to the name field. The same is true for the methods we call in a person. Now, as I said, this is the easy way of integrating a person into an employee struct, by using a person field. But I wanted to show you how to embed a person struct into an employee. You can do that by simply omitting the name of the field and just putting in the name of the struct. You can see that within our main function, especially in the way of accessing the person fields, nothing has changed. But if you now try to access the fields of the embedded person, you directly have access to those as well as all the methods of a person. If we hover over the full name function, we can see it's still the method of a person struct and not a function of the employee struct. Okay, now why would you use embedding? Basically, it's just syntactic sugar that helps you write cleaner code, and it's mostly used to reduce the number of fields used between structs. You can think of embedding like using a basic struct. In our case this would be the person and all of its fields. If I would have to define the employee struct without the person, it also would have a name, a last name, an age and an address. So it kind of makes sense to take all these fields and put them into a separate struct, the basic struct person, and then embed it into the employee. This is why embedding a person made sense in this case. If you would go ahead and define another struct like a freelancer who does not have a salary but gets paid by writing invoices, we could still embed the person struct because every single freelancer also has a name, a last name, an age and an address, right? Whenever you have common fields among your structs, you might consider using a basic struct and embedding it. Keep in mind though that embedding is used for shared data. If you want to have shared behavior, this is what interfaces are for, which I will go over in the next tutorial. And that is it for structs. If you found this video helpful, please leave a like and subscribe to the channel if you're new. And until next time, keep on coding!